Hey everybody, so we didn't have a whole lot of time in class to finish up the discussion, and we didn't get to talk about square root inequalities, so I figured that this would be a good time for me to get back into videos. In fact, I think that we are going to move more towards homework and some videos once we get back after our midterm, so hopefully this is good for everybody. You want to get your graphs back out for your homework, so if you need to pause this video for a second and get out these graphs that we worked on in class. I want to take a few minutes to talk about the domain and range of these four graphs. The first one, when we just multiplied by 2, we are stretching the graph up, but we are still bound by this 0, 0. So if we're going to talk about our domain is still going to be x has got to be greater than equal to 0 because we're not going any further left than 0. And our range is not going to change because we're going up. We're still going up. We're still in quadrant 1. So y is going to be greater than or equal to 0. If you notice, in quadrant 1, x is greater than 0. Y is greater than 0. We're only using this part of the x-axis and this part of the y-axis, the positive part. If we look at number 2, things change. For the x-axis, we are still putting in positive, so our domain is going to be x is greater than or equal to 0. And our range is going to be different. Because we reflected about the x-axis, we're not using the positive part of the y-axis anymore. We're using the negative part of the y-axis. So y isn't going to be greater than or equal to 0. Y is going to be less than or equal to 0. If your x is positive and your y is negative, then you're going to be in quadrant 4. If you look at the third graph that we have right here, and we want to talk about domain and range. The domain is the part of the x-axis that we use. Because we have a horizontal shift to the left 3, we're not going to just be greater than 0. We're going to come all the way over to where our function starts at -3. So our x can be equal to 3, but all the other, equal to -3. But it has to be greater than or equal to -3. We're not going to the left of -3. All of our coordinates are going to be greater than or equal to -3. And then if we want to talk about our range, our y, however, is still at 0. We stopped at -3, 0. We didn't go any further below that x-axis. So our range is going to be y is greater than or equal to 0. The last function that we talked about in class, if we want to talk about, here we have a horizontal shift to the left 4, and then we have a vertical shift down 2. So the horizontal shift is going to deal with what happens to our domain, our x-coordinates, and the vertical shift is going to affect what happens to our range, or our y-coordinates. So my domain, in this case, is going to be x has to be greater than or equal to, and if you look, we're going all the way over to -4 on the x-axis, if you were to draw a little dotted line. So it's got to be greater than or equal to -4. My range deals with my y, and on my y-axis, I'm actually at -2. I'm not going below -2, I'm going greater than -2. So y is going to be greater than or equal to -2. Now I hope this is making sense as to how you can describe your domain and range. We are going to have some problems. I do expect you on your test to be able to understand the domain and range and how to just simply graph a square root function. we talked, or when I first introduced this, I said that we were going to do square root functions and inequalities. So let's look at what happens if we want to apply an inequality to this situation. If we look at our original, we want to compare to our square root of x. We have a -5 underneath the radical. If it's underneath the radical, and we go back to what happens with the transformations, if that number is underneath the radical, that means it's left and right. The minus means that it's going to have to be the opposite. So where it's a -5, that actually means that we are going to move to the right 5 units. We're taking our original parent function of the square root of x, and we're moving to the right 5 units. And then this +3 hanging out here, that is our vertical shift. That's going to move us up or down. So because it's a +3, that means we're going to go up 3 units. So we're starting here at 0, 0. We're going to move to the right 1, 2, 3, 4, 5, and up 1, 2, 3. So this is my new 0, 0. And if you remember, you can make a table. It's fine to make a table. If you just find that starting point, that's going to help you know what to plug in. The issue is if you plug in a 0, 0 is not going to work because 0 minus 5 is -5, and you cannot take the square root of -5. That doesn't work. So that's where we get imaginary numbers, and we can't graph imaginary numbers. The smallest number that we can plug in for x is going to be 5. If we plug a 5 in, 5 minus 5 is 0. The square root of 0 is 0, and then you have +3. So 5, 3 is my first answer. If you plug in a 6, 6 minus 5 is going to give me 1. The square root of 1 is 1, and 1 plus 3 is going to give me a 4. So that's where I'm going to get my next point. If you think about your square root, you have your 0, 0, your 1, 1, and then the next major point you have is 4, 2. So you also can go over 1, 2, 3, 4 and go up 2. That's just kind of like we memorize particular things about functions. That's what I have memorized. I've got my 0, 0, my 1, 1, and then over 4 and up 2. If you want to check your math, this would actually be, if this is 5, 6, 7, 8, 9. 9 works because 9 minus 5 is 4. The square root of 4 is going to give me 2, and 2 plus 3 gives me 5. So that's how I get that coordinate 9, 5. Now, I drew a solid line this time, and it's legal for me to draw a solid line because this symbol is less than or equal to. Had the symbol been just less than, I can't draw a solid line. I have to draw a dotted line. Now that we have less than or equal to, I can shade less than. It's going to be down this way. But we can't go past that 5. All of these coordinates will work for less than, but we can't go past that line for our domain, because our domain is still going to be greater than or equal to 5. We have a bar that stops us right here. If we put anything less than 5 in, we're going to get an imaginary number, and that's not going to work even with an inequality. We can't graph imaginary numbers, whether it be equal to or an inequality. Now, if we look at number 9, here we have our square root function. We have a negative in front, so that means we're going to reflect. This negative tells me we're going to reflect over the x-axis. And this +2 is underneath the radical, so that's going to be a horizontal shift. Horizontal shifts are the opposite. So horizontal shift to the left 2. So we start at 0, 0. We shift to the left 2. I don't have a vertical shift, but instead of going up 1, 1, I'm going to go down 1, 1. 1, 2, 3, 4, 2. That's my next point that I have memorized. So this, oh, I caught myself. I can't use open point or solid points. I have to use open points. And the reason I have to use open points is because it's greater than, not equal to. 2, 3, 4, down 2. That also means I can't draw a solid line. I have to draw a dotted line. And if I want to shade greater than, that means it's going to be coordinates up here. Now, for those of you who don't like moving the basic parent function around, you can make a table. If you can at least figure out where to start, if you plug in a -2, -2 plus 2 is going to give me 0. And it doesn't matter if 0 is negative. -1 plus 2 is going to give me 1. And the square root of 1 is 1. But because there's a negative on the outside, that's why I went to -1, -1. If I plug in a 0, the square root, that's just going to give me negative square root of 2. Well, that's about 1.4. So I did pretty good guesstimating. And if you want to see if 1, 2 works, if I plug in a 2, 2 plus 2 is 4, which gives me the square root of 4 is 2. So my answer should be -2, which is where I'm at, 2, -2. Hopefully, you can see your relationship here. This is what I'm going to check on Monday. I want to see that you graph these two absolute value inequalities. I hope that you are starting to see the relationship between your square root function. I think I said absolute value. I meant square root. Your square root function and your parabolas, or even the square root function and your absolute value function. We shifted it left and right and up and down in this same way. Well, I only have 2 minutes left, so I hope you have a great weekend. Once again, I need you to write all of this down, your relationship for the absolute value inequalities, and we will be reviewing for the test on Monday. Bye.